Hello, and welcome to the ACS Organic Chemistry final review. This one is going to be on nomenclature and testing strategies to help you with that exam. So there's going to be two primary ways of doing this, either with the giving the name and going to the structure, or having the structure and then going to the name. And so we'll review both of those sorts of ways. But remember, for these sorts of exams, right, because it's multiple choice, you can always say what it's not, and so we can start eliminating things. We don't necessarily have to completely answer the problem if we know what it's not. How about that? So the first thing, right, so is to get a name and go to a structure. Okay, so for this one here, right, it's usually easier to go backwards with the name. So for this one, right, so we know that it's, because it's hept, it's going to be 7 carbons long. That's the main chain, right? But it does have a double bond in it, starting at carbon 3. With that, and so we can eliminate anything that doesn't have 7 carbons. So as the main chain, right? So for here, it's 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. Here, 1, 2, 3, 4. But remember, we because we haven't had to pick up our pen, right, we can keep doing the main chain around like this. So it becomes 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. Okay, so there's only 6 carbons in here on the main chain, so we can get rid of that one. Now here, the double bond is going to start at carbon 3. So in this case, right, so this is the end closest to the double bond. So here it's going to be 1, 2, 3. For here, it's going to be 1, 2, 3. So for here, it's 1, 2, 3. Okay, so that's okay. Now for this one, remember, right, this is the end that's actually closest to the double bond, right? Because 1, 2, 3. Well, actually, it doesn't really matter, but because it'd be 1, 2, 3 versus 1, 2, 3. But remember, sometimes it's the end that's closest to the double bond that is going to be carbon number 1. Okay, so all of them have the carbon starting at carbon 3, so we're good on that one. Now we also have a chlorine, right? Remember, it's at carbon 4. Okay, so here it's going to be, right, carbon 4, but this one here, notice how it's at carbon 3, so we can get rid of this one, and then here it's going to be at carbon 4. So we're actually down to these two. So even if you don't know what E and Z is, if you don't remember, you have a 50-50 shot. Okay, so for Z, for the E and Z, right, what we're going to do is we're going to check out the two things that are the two groups that are hanging off of this carbon versus the two groups that are hanging off of this carbon. Okay, and we're going to assign the pair priorities, a high and low, and we're going to use the same sort of priority rules that we did for R and S. Namely, it's going to be on mass, things like that. And so for this one, right, so we have chlorine versus carbon, right? So chlorine is heavier, right? So we're going to have, so this is going to be the high, this is going to be the low. Okay, and then we look on this side, right? So we have carbon versus, over here there's going to be a hydrogen, right? There's a hydrogen here, right? Because there's only 3 bonds shown. So in this case, we're going to be the high versus low. So then you look to see where the highs are. If the highs are on the same side, right, in your best bad German accent, right, then the molecule's in the Z configuration. If it's if they're an opposite, then it's then they are not on the same side, right? Then it's E. So in this case, right, so they're both pointing up like this, and so this is the Z configuration. For here, right, so just as an aside, right, so here we have high and low. Here we have high and low. Right, if we look at these two versus those two, right, if you want to slice it, you can. Right, so for here we've got this one going up, this one, the high, going down, and so in fact this is the E. So the other way to do this is to take a structure and then get the name, right? So notice these are all octenes. So 1, 2, 3, 4, 5, 6, 7, 8. Right, so that makes sense, right? They have a double bond in them, right? For here, and then this is a ketone. So, okay, so really the distinguishing difference between these guys, these different names, is the E versus Z, as well as what's the priority. Okay, so we'll do the E and Z first. Okay, so draw on the hydrogen. That's the easiest thing. Right, so we're going to look at this carbon, so that the two groups, right? So this is carbon versus hydrogen. So this one here is the high versus the low, and then on this side, right? So again, we have carbon versus hydrogen, and so we have the low and high. So here the highs are not on the same side, right? So we're up versus down, so like that. And so we know that this is definitely going to be an E, so we can get rid of any of the Z's. Voila. Okay, now the next step is going to be basically, is the ketone on carbon 2 or carbon 5? Right? 1, 2, 3, 4, 5, 6, 7. Actually, this should be 7. So what we're going to want to do, right? So we have to think about, because we have two functional groups, right? We have to think about priority, and the way that usually works with priority is carbon-oxygen bonds are higher priority than carbon-nitrogen bonds, which are higher priority than carbon-carbon bonds. Okay, so the more of the carbon, more heteroatom bonds that would make up that functional group, the higher the priority. Okay, so for example, a carboxylic acid is going to be a higher priority than a carbon than an aldehyde, right? But even then, say an amide is actually going to be, in between, right? Because it has three heteroatoms hanging off of three heteroatom bonds hanging off of the carbon, but it's going to be a lower priority than the carboxylic acid or the ester, because this has 3 carbon oxygen as opposed to 2 carbon oxygens and a nitrogen, carbon nitrogen. But then which would be aldehyde, and then say an alcohol, right, versus an amide. Now, carbon double bonds, actually this is the weird one, they actually have a higher priority than carbon triple bonds. That's the only one, really weird one. You just have to know with that. So I don't know if it's an alphabetical thing or a reactivity thing, I don't know. Stuff like that. And so for this one, right, we have a carbon double bond versus a carbon oxygen double bond. Okay, so this is going to be the higher priority, so that means this end is going to be carbon 1, 2, 3, 4, 5, 6, 7, 8. Okay, stuff like that. And so for this one, it's going to be A. Sorry about the mistake here. So, okay. Oh, I should mention the IUPAC. So that one is the, it just means it's the very technical name for it, as opposed to sort of a more common name. So that's all it's saying. Now for naming benzene molecules, okay, this is a slight different, okay, because IUPAC knows that, says like, okay, we can deal with these base names, okay, stuff like that. So these ones you just need to know. The other one, actually, I don't have on here, is xylenes. So these have 2 methyl groups on them, and you can either have the ortho, the meta, or the para, depending on the relationship between these two here. Stuff like that. But these are ones you just need to know, stuff like that. So now, if you have more, if you don't have one of these base names, so let's say you have a chlorine and a bromine on there, right? That's not one of the base names. That makes the base name just benzene. Okay, stuff like that. So, but for this one, you need to know these. Now, if you have more than one, okay, these, the toluenes and xylenes are always going to lose to these guys here. I'm sure that there's a list out there that shows the priorities. I just don't have it off the top of my head. But I do know that toluenes and xylenes are always a lower priority than these other ones. Okay. So with that said, okay, we can look at this molecule, right? And here's one base name or base structure. This is aniline. The other one would be, right, because these two are just methyl groups, right? This is the xylene. Now, we just said that the aniline is a higher priority than xylenes and toluenes, things like that. So, so we can get rid of this one. Okay, so the xylene, right, we can get rid of that one. Also, the toluene, right? There's actually 2 methyls on here. We can get rid of that too, right? Because toluene can only have the 1 methyl group. Okay, so that means aniline. Now, for naming these things, so we're going to say this is the base name. So the functional group that's that makes the base structure, that makes this carbon 1. Okay, no matter what. So then you go clockwise or counterclockwise. So clockwise would be 1, 2, 3, 4, 5, 6. Right. So this would be 3, 4. Right. Versus 1, 2, 3, 4, 5, 6. Okay. So this would be 4, 5. Right. Just to make sure everything's okay on this. So this is 7 versus 9. So you want to do this name anyway, and so it ends up being that one. Okay. Never a bad idea to go just do clockwise, counterclockwise. It takes 5 seconds and you're fine. So. Okay. Lastly, you do probably need to know what the different functional groups, although at this point you've probably used them enough to know, but do go back and look over them again, just as a refresher. Okay. Now, one of the things is they won't always be drawn like this. Sometimes they'll be drawn as a condensed structure, and so for those, the aldehyde is typically shown as a CHO. Okay. So that is to distinguish it from a COH, which is going to be an alcohol group. Okay, an ester is typically just CO2, and then there'll be carbons on either side of that, and the carboxylic acid is going to be CO2H. So just be aware of these abbreviations, particularly the aldehyde. Don't think that it's an alcohol. If it's an alcohol, it's usually listed as an OH, and aldehyde is CHO. Okay, so for aldehydes, right? So unfortunately, you guys won't be able to write on your paper, but you can. Fortunately, I can. So for the aldehydes, right? So it's here, 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 and here. Okay. So for the esters, right? So we need a C double bond O with carbons on either side. Doesn't really matter what they are. So ester. Here's an ester. Here you have a C double bond O, C double bond OH. That's a carboxylic acid. But here it's a C double bond O with just carbons on either side. So this one's a ketone. So that's not going to work. And then here we do have the ester here because this ends up being a CH3, right? So with carbons on either side. So here's our ester. Now for this one, for the carboxylic acid, right? We have it here because we end up at C double bond O OH. Okay. Here we have a C double bond O. And an OH, but there's this CH2 in between. Okay, so this actually functions as a ketone and a carboxylic acid, so like that. So that's not going to work. So, and then here we have the just an alcohol. So this is an alcohol. So this isn't going to work. Okay, so it ends up being this one here. So, good luck.